Hi everyone! We are here to celebrate the landing of Perseverance, the newest NASA rover that will touch down on Mars. Let's explore the book, Mars Rovers by John Hamilton. Humans first landed robotic spacecraft on the surface of Mars during the 1970s. Scientists gathered a huge amount of data from these stationary machines. In 1971, the Soviet Union tried to land twin probes on Mars. They were part of the Mars 2 and Mars 3 missions. These probes included small rovers, called Prop-M rovers, that were about the size of a video game console. They had movable skis to help them shuffle along the Martian surface. Unfortunately, both Soviet landers failed and the rovers never had a chance to perform their mission. NASA's Viking project became the first successful mission to land safely on the surface of Mars when the Viking 1 lander touched down on the western slope of Chris Planitia and the Viking 2 lander settled at Utopia Planitia. Besides successfully returning images of the red planet's surface, they performed biology experiments designed to look for possible signs of life. Both landers, while designed to function for only 90 days, operated for several years. The Viking 1 lander sent its last transmission November 11, 1982. However, to learn more about the red planet, a new generation of mobile science laboratories were designed. These new roving labs were packed with experiments to test Mars' atmosphere and soil. They even have cameras to capture images of the alien landscape. Most importantly, they can move across the Martian surface. The spacecrafts were no longer stuck in one spot. These rovers have been traveling across Mars on missions for the past several years. On December 4, 1996, the United States launched a new lander named Pathfinder. Pathfinder blasted off from Florida's Cape Canaveral Air Force Station atop a powerful Delta II rocket. On July 4, 1997, after a trip of more than 300 million miles, it reached Mars. Operating completely on its own, it entered the red planet's atmosphere at about 16,000 miles per hour. Aerobraking through the thin atmosphere helped Pathfinder slow down to 800 miles per hour. Protected by a heat shield, the spacecraft blazed a fiery trail across the pink Martian sky. Several miles above the surface, a huge 36 feet in diameter parachute opened, slowing the spacecraft down to about 160 miles per hour. 80 seconds from touchdown, about 3 miles from the surface. The main lander was quickly winched down from the rocket pack. The lander used radar to measure its distance from the surface. 8 seconds before landing, sets of large airbags were rapidly inflated that protected the precious cargo inside. Braking rockets fired briefly, and Pathfinder free fell to the surface of about 40 miles per hour. Once it landed, the airbags slowly deflated, and the lander's 3 solar panels opened like a big metallic flower. When the sun rose, it began powering the probe's instruments, sending photos back to Earth that morning. Piggybacking on Pathfinder was a 6-wheeled microwave oven-sized rover called Sojourner. The rover was named after the African-American Civil War abolitionist Sojourner Truth. The word Sojourner means traveler. The Sojourner rover was about 2 feet long and 1.5 feet wide and a foot high. Weighing in at 23 pounds, it had cleats on each of its 6 wheels to give it traction in the dusty Martian soil. A solar panel on the rover's roof provided power, while 5 lasers helped controllers on Earth identify and avoid obstacles. It also had 2 small black and white cameras mounted on the front to take stereo pictures and a color camera on the back. An alpha proton X-ray spectrometer identified the kinds of rocks and soil Sojourner would discover. Sojourner then rolled down a steep ramp toward the planet's surface. This process took controllers at the Jet Propulsion Laboratory in Pasadena, California, most of the day. Sojourner analyzed Martian rocks and soil and took pictures. It never roamed more than 30 feet from Pathfinder, and for 10 hours sent data back to the lander to relay the information to Earth. Pathfinder was designed to last 30 days. Sojourner was expected to last just 7 days. However, both machines kept working for several more weeks. By mission's end, the lander had sent back more than 16,000 images, along with additional 550 from Sojourner and more than 15 chemical analysis of rocks and data about Mars's weather patterns. After the success of the Pathfinder mission in 1997, NASA prepared to send twin rovers to the red planet. The two Mars exploration rovers were named Spirit and Opportunity. The golf cart-sized rovers were designed and built at NASA's Jet Propulsion Laboratory. They chose two landing sites. The Spirit rover would be going to Gustav Crater, a 103-mile-wide basin that may once have held a lake. Opportunity would land in a broad plain called Meridiani Planum. Spirit and Opportunity were about 17 times heavier than the Sojourner rover. The Pathfinder lander not only housed Sojourner, but also heavy communication equipment for contacting Earth, plus cameras and computers. Spirit and Opportunity carried all that equipment themselves. Their landers were built to protect them in flight. Once on the ground, the landers would unfold. The rovers would roll down a ramp onto the Martian surface, and the lander's mission was complete. Spirit lifted off from Florida's Cape Canaveral Air Force Station on June 10, 2003. Opportunity followed on July 7, 2003. Each rover was tightly packed inside its lander. Spirit was the first to arrive at Mars on January 4, 2004. Protected by airbags, Spirit hit the ground. It rolled and bounced 28 times before finally coming to rest inside Gustav Crater. After traveling 303 million miles, it was a near-perfect landing. For the first couple of weeks, Spirit slowly roamed around the landing site. It took pictures and analyzed the area's geology. A computer glitch struck Spirit during its third week on Mars. As computer experts on Earth worked on Spirit's problem, the Opportunity rover arrived. It landed safely at Meridiani Planum on January 25, 2004. After bouncing 26 times on its airbags, it came to rest in a shallow depression called Eagle Crater. It landed just 16 miles from the center of its target zone. With Spirit's computer problems repaired, both rovers now roamed Mars. Spirit and Opportunity each lasted much longer than scientists had planned. Their main missions were only scheduled to last 90 days. However, each rover spent many years roaming the Martian surface. In 2009, Spirit's wheels got stuck in sandy soil. Controllers tried for months to find ways to free the rover, but were not able to. Spirit sent its last radio signals to Earth on March 22, 2010. Due to a planetary dust storm on Mars, Opportunity's mission came to an end in June 2018 after exploring Mars's geology and weather and taking more than 228,000 breathtaking photos. The next rover designed to venture to Mars was Curiosity. It is the biggest and most technologically advanced rover to ever land on Mars. Part of the Mars Science Laboratory mission, the Curiosity rover took more than 7 years to plan, build, and test. The Mars Science Laboratory was equipped with computers, rockets, and fuel. A 14.8-foot heat shield protected the rover during its trip through the Martian atmosphere. It took 8 months for the Mars Science Laboratory spacecraft with Curiosity aboard to travel 353 million miles and reach Mars. Curiosity landed on Mars on August 6, 2012. Unlike previous rovers, Curiosity was too heavy to land safely using airbags to cushion the impact. Instead, it used a radical new method called a sky crane. The rover was lowered from the upper stage spacecraft to the ground by 3 21-foot-long nylon ropes. This kept the rover far away from the spacecraft's retro rockets. Otherwise, they would have stirred up dust and rocks on the Martian surface, which could have harmed the rover. Curiosity made the almost pinpoint landing inside Gale Crater in the Elysium Planitia region of Mars. The landing site was named Bradbury Landing in honor of Ray Bradbury, the science fiction author. Curiosity is bristling with scientific equipment. It has spectrometers and lasers that analyze the chemical elements in rock, soil, and air samples. It also has a radiation detector and 17 cameras. Some take high-resolution photos of the Martian landscape, while others help avoid hazards while roaming. The rover is also equipped with a 6.9-foot-long robotic arm. There are several instruments on the arm, including a close-up camera, X-ray spectrometer, drill, rock cleaning brush, and scoop. After drilling 0.6-inch wide holes in rock or soil, the arm gathers up the powdered samples and moves them to chemistry labs inside the rover. About the size of a small car, Curiosity has 6 wide wheels with a suspension that is similar to its predecessor rovers Spirit, Opportunity, and Sojourner. It allows Curiosity to roll over tall obstacles and climb steep hills. Curiosity was built much bigger so it could hold more scientific instruments. The rover measures 10 feet long, 9 feet wide, and 7 feet high and weighs nearly 1 ton. Previous Martian rovers got their power from solar panels. However, dust often gathered on the flat panels and reduced the amount of sunlight that could be used to generate electricity. Instead of solar panels, Curiosity has a radioisotope power system. It uses the heat generated by radioactive plutonium-238 and converts it to electricity. It is very dependable and provides more than enough power for roaming the Martian landscape and for the rover's instruments. As of February 2021, Curiosity is still roaming Mars and sending back data along with images of itself and the Martian landscape. It is now time for the next rover to make its way to Mars. Perseverance is scheduled to land on the surface of the red planet February 18, 2021, and this time a little helicopter named Ingenuity is along for the ride. The Mars rover Perseverance is based on the Mars Science Laboratory's Curiosity rover configuration. It is about 10 feet long, not including its arm, 9 feet wide, and 7 feet tall. At 2,260 pounds, it weighs less than a compact car. It includes all the parts Curiosity had and more. Perseverance will be the first rover to bring microphones to Mars. This will allow us to hear the sounds from the red planet for the first time. Other instruments and upgrades include a laser microimager, an ultraviolet and X-ray spectrometers, a weather station, subsurface radar, and an instrument called MOXIE, which produces oxygen from the Martian CO2. The rover also has a drill for soil samples that scientists hope can be sent back to Earth in the future. One of Perseverance's main upgrades is that it can self-drive for up to 200 meters per day and build a map of the surface it is driving on. It is also home to a small drone-type helicopter named Ingenuity that will attempt the first powered flight on Mars. At only about 4 pounds, Ingenuity is what is known as a technology demonstration, a project that seeks to test new capabilities for the first time with limited scope. Ingenuity features 4 specially made carbon fiber blades arranged on 2 rotors that spin in opposite directions at around 2,400 rotations per minute. That is many times faster than any passenger helicopter on Earth. It also has solar cells, batteries, and other components, but no science instruments. It is a separate experiment from Perseverance. Ingenuity will be the first aircraft to attempt a controlled flight on another planet. It has 4 milestones to reach before it is able to take flight. First, survive the launch, traveling to Mars, and the landing. It then needs to safely deploy from Perseverance's belly. It needs to keep itself warm through the Martian nights that sometimes reach minus 130 degrees Fahrenheit, and then lastly charge itself with its solar panels. Each one of these milestones is an achievement on its own. Once all milestones have been reached, Ingenuity will conduct its first simple vertical flight and landing. If successful, it will be followed by a series of 4 other test flights within a 30 Martian day window. The technologies demonstrated could enable other future advanced robotic or human missions to Mars. With a little travel, spirit, curiosity, perseverance, and ingenuity, who knows what we can discover on Mars? Thank you for joining us, and I hope you are as excited as we are to see history in the making with the arrival of Perseverance, the next Mars landing. Now, join Ms. Rochelle for 2 fun hands-on activities in the art studio. Thank you so much, guys. Bye-bye.
Welcome to the Cerritos Library. My name is Ms. Rochelle. Today, I'll show you how to create 2 different helicopters. The first helicopter is made with marshmallows and is based on the Mars helicopter Ingenuity. The other helicopter is made with paper and is easy to create. Join me in the art studio and we'll get started. The materials you'll need to build your helicopter are 1 large marshmallow, 4 small marshmallows, 5 toothpicks, scissors, a thumbtack or pushpin. Build your own Mars helicopter directions. You may want to print the last page on cardstock, and if you like, you could print an image of Mars to place your helicopter on. You can locate these directions and images by going to cerritoslibrary.us, then click on the link for Mars landings and the arrival of the Perseverance rover under the What's New tab. Okay, the large marshmallow for this project represents Ingenuity's fuselage. We're going to insert 4 toothpicks into the marshmallow so they come out at an angle. These toothpicks represent the 4 hollow carbon fiber legs on Ingenuity. Now we're going to take the small marshmallows and place them on the end of each of the 4 toothpicks. These make the ends of the legs look round, just like on Ingenuity. We're going to now take the last page of the PDF and cut out the solar panel and 2 rotor blades. Then we're going to have this. Have a parent help you make a small hole in the middle of the parts you just cut out. We're going to place a small hole in the middle of the solar panel and a small hole in the middle of each rotor blade. Now I'll push a toothpick through the hole in the center of one of the rotor blades. I'll take the toothpick and push it through the second rotor blade. Make sure the blades are aligned in different directions so that there is a small space between the blades. Then we'll put the solar panel on top of both of the blades. Just like this. Now we'll place the toothpick in the center of the large marshmallow. If you printed an image of Mars, you can take the image and place your helicopter on top. And now your helicopter is complete. To make the helicopter, the materials you'll need are scissors and Make a Mars Helicopter template. You can locate this template by going to cerritoslibrary.us, then click on the link for Mars landing and the arrival of the Perseverance rover under the What's New tab. The first step is to cut out the helicopter. Once you cut it out, you'll have this. The next step is to cut along the dashed lines. Then you will need to fold along the solid lines. Fold the X and Y panels towards the center. And Z is folded upward. Make sure propeller blades A and B are folded in the opposite directions. Your helicopter is ready for flight. 3, 2, 1. You can locate these coloring sheets by going to cerritoslibrary.us. Then click on the link for Mars landings and the arrival of the Perseverance rover under the What's New tab. I hope you enjoyed our program about Mars landings. Be sure to watch the Mars Perseverance rover landing on February 18th, 2021. Bye-bye.